So without any further ado, I would like to start off this session of the Smart Contract Essentials with Austin Griffith. So we have Austin here, our speaker. So a little bit introduction about Austin. Austin builds a lot of random things and tries to teach other developers too. He works for Ethereum Foundation, focusing on developer onboarding, mentoring, and tooling. So he lives in Fort Collins, Colorado. So, Austin, we are very lucky to have you here. And I know some of the members have already seen some of your YouTube videos, the way you teach. And we are, thank you so much for your time and looking forward to your session. Over to you, Austin.
Awesome. Thank you for having me. Hello, everyone. Good morning, good evening, good day, GM. I'm just going to put a GM in the chat. Throw GM in the chat if you're around. Thanks for having me. Yeah, this is like a worldly group here. Just looking at the names and the locations, this is really cool to get to have this kind of 1 hour experience of let's get into smart contracts and let's learn kind of just the essentials of getting started with smart contracts with this group here. And I'm going to keep a close eye on the chat, so feel free to ask questions as we go. If we're ready to get started, I will share my screen and get started. If there's anything else we need to talk more through, or should I just get going? I'm going. Okay, here we go. All right. So let me share my screen, and I'll keep an eye on the chat. I think the first thing to point out is just like Ethereum.org. If you are, hopefully that's yeah, it's got to be. Let me just triple check to make sure I'm sharing the right. Yeah. Oh yeah, that's the right one. Okay, Ethereum.org is just a great place to start. You can go here and just like learn a lot of the basics. I think this is session 4, so I'm assuming that folks that have gotten this far, you kind of understand the basics of blockchain, you understand the basics of decentralization. I guess if we were to TLDR, I mean, there's a lot of great stuff you can learn here if you just like learn what is Ethereum and learn a lot of this stuff. But the big TLDR here is that Web3 is all about decentralization. It's about a lot of these nodes. If you can see in my camera here, let me actually go back to camera real quick. If you can see right here in my video, this is an ETH2 node, and there's an ETH1 node kind of sitting there. But that's kind of the substrate that we're running on here. Is there's all these machines all around the world hosted by people like me that have these nodes running. And what we're talking about today is smart contracts and deploying apps that sort of run on this substrate of Ethereum. But before Ethereum, if you wanted to make a decentralized currency or something like that, you basically had to do this. You had to incentivize a large network of thousands of nodes to communicate peer-to-peer and come to a consensus and basically mine those blocks. But now we have Ethereum, and that layer is sort of taken care of for you. And what we're learning today is how to deploy apps on top of that layer. So just kind of giving that kind of basic introduction at first. It's all about decentralization. Bitcoin came before Ethereum. Bitcoin is about that hard decentralization. You'll see with Ethereum, and I think you guys talked about it probably in a previous session, that there are forks of Ethereum, and it's slightly more malleable, but still very decentralized. And for us as builders, it's really, really easy for us to make just a couple simple rules and deploy those simple rules to all those thousands of those nodes and have this app run decentralized. And what I mean by that is no one can stop it and everyone can get to it. And so if even if I wanted to stop it, I can't, right? Even the person who deployed it, if it's deployed correctly, it can't be stopped. And that's kind of the power of decentralization, that layer of redundancy of thousands of nodes all running the same exact program. And we'll get into how to build those programs today as we kind of discover more about smart contracts. So Ethereum.org, great place to learn about Ethereum, great place to get started, just getting the how and the why for decentralization, great place to go find a wallet and learn more about NFTs and DeFi and smart contracts in general. But if you're a developer and you're a builder, you've probably used a few of those things already, and now you're looking at how do I build on top of it. If you haven't yet, go get a wallet, go get an ENS address. You'll depending on what country you're in, you'll have different on-ramps into that. In the United States, we have Coinbase. I don't know if Coinbase is there, but you'll find a ramp. You connect your bank account, you put $100 in or whatever, and then you have money on chain, and then you can use that money for gas to make transactions and deploy contracts and all sorts of fun stuff that we'll get into today. But if you don't have a wallet, if you haven't used it yet, go use it. Go become a power user first. Get a wallet, get an ENS address, buy an NFT. I don't know. There's lots of fun things to do. Swap ETH to DAI and understand stable coins and a lot of other stuff like that. But what we're talking about today is how to build smart contracts and how to build on top of that layer. So I'm assuming that a lot of this stuff is already kind of covered, and I'm going to kind of dive into the Solidity. Another great place to get your fundamentals is from eth.build. I'll paste that. Actually, here, let me just, while we're pasting chats, let me make sure I paste this. Oh no, I've already lost the chat. Hold on. Here we go. Okay, there we go. So there's ethereum.org. Oh, I got the /n, the en, but there's ethereum.org. Now, the second resource I want to put in front of you for fundamentals, if you haven't kind of learned blockchain, distributed ledger, key pairs, transactions, hash functions, you can do that here on ETH Build. And it will kind of take you through, it's like old videos of mine, but it will take you through kind of these concepts. And really, let me just dive in and try just building something real quick just to show it off. So it shows off, let me see if I zoom way in, we should have a nice big thing. But like a hash function is very, like I can write hello world and we get that hash kind of on the other side there, right? And that's a deterministic hash of hello world. Then the key pair is another really important thing. So this is, you've probably learned this already. I know I'm probably recovering things, but just to make sure we have the background we need, you can generate this private key, and this private key is sort of your address, and that's what people send to, and you can kind of tinker around with this. You can even sign and recover data, and you can go through this and find all sorts of things. Like we can go grab the current, I don't know, like the current block number on Ethereum is right there, right? And as a new block gets mined, we'll see that number change. So you can do lots of things like poke at, you know, if I unlock my MetaMask, or maybe I want ENS or something like that. You can do a lot of stuff with tinkering around, but ETH Build is just to get the fundamentals and to teach you kind of like the early fundamentals of Ethereum. Now, I'm going to assume that basically the crew here understands the how and why of decentralization, proof of work consensus, public-private key pairs. Now we have this awesome network of Ethereum deployed for us. And what we're going to do is we want to build something on top of it. We want to build something at the application layer. And it's very similar to Web 2. Web 3 is very similar to Web 2. But in this case, we're going to have a little bit different backend, right? Our backend will be Ethereum, and it'll be kind of like a slow, expensive, asynchronous database with these really cool trust assumptions that anyone can get to it, right? And no one can stop it. And when I zoom in on trust there, let me just talk about escrow for a second. If I wanted to sell a pair of shoes to someone that I don't trust, I kind of would need someone in the middle, right? I would need to give that shoes to the person in the middle, and they would need to take the money. And then if that person in the middle kind of got both the money and the shoes, they could do the swap and give the shoes to me and give the money to someone else. There's this person in the middle that you have to trust if you don't trust other people. Well, in this case, the blockchain, Ethereum, the code is the thing in the middle. The code is the only thing you have to trust. You write a little bit of Solidity and anyone in the world can get to it, and everyone in the world can see exactly how it's going to run, and the code is law, right? Like the code will do exactly what you tell it to. The code will do exactly what it's programmed to do. Sometimes we get that wrong and we mess it up a little bit, but the code is the thing that you have to trust, right? The code is the thing that we back to in terms of trust. And so this is what we're trusting. And so this is kind of where we're going to be really zoomed in today, just looking at how to write some basic smart contracts and what they look like and kind of the gotchas there. So we'll be using, so let me just also say that Remix is available. If you don't want to spin up a local environment, if you'd like to just go tinker with your contracts, there's always Remix, where you can get in here and kind of set Let's see if I can figure it out. Let's see. There's like an owner, there's some storage. Okay, so yeah, so this contract has a number and it lets us store the number and it lets us retrieve the number, right? And if we compile that and then we deploy it, we should get down here, we should get, there's our storage number. And if I put an 8 in there and I say store, and then I retrieve, it's 8, right? And if I change that to 10 and I store and I retrieve, that's 10. So this is probably the fastest way to just like, I have to go check this one thing in Solidity. How do I do it? Like, what if I make this a uint 8, right? What's gonna happen there? This is a good place to do that. And I want to make sure to surface it so people know about it. But what we're going to be talking about today is Scaffold ETH. And the small difference here is it gives you that same experience where you can tinker with your smart contract and you'll get a front end that you can interface with your smart contract. But the way Scaffold ETH works is you have a local environment. It's kind of like WordPress was back in the day. Scaffold ETH is kind of like this template for building apps. And so it's just a way to like very quickly prototype ideas and tinker with your smart contract as you go. So you'll clone down Scaffold ETH and you'll need Yarn. So Yarn is probably one of the kickers that people run into now and then. Now, I'm assuming that you know how to install Node and NPM. If you don't, you'll need to have those, and there's some, but once you have those, you can just do npm install -g yarn, and that's how you get Yarn. Let's zoom way in on that. Sorry, so that's one little piece of setup that you'll need, is to make sure that you have Yarn installed that way, and then you should be able to Yarn version and get your Yarn version and Node version. We can get that right. Make sure we have, oh, it's -- version. So we've got all the prereqs. Yeah, go ahead. Yes, please.
Hi, Austin. Sorry. So there was a comment that if you could zoom in on the the terminal, command terminal, that would be great.
Yeah. Let me get those. Yeah, let me get those a little bigger. I'll make all of those a little bigger as we go. Yeah, so we've kind of got our prerequisites down. You'll need Node and Yarn and Git. I'm going to assume that you have those and have those figured out. If not, hit me on the DMs. I am, let me just throw my Twitter in here too while I'm here. If I go there we go. DMs are open if you get stuck on something. There's also the Scaffold ETH Telegram channel. Let's see, can I zoom in here too? Okay. Trying to be zoom aware here. Let's see. What I want to do is I'm just going to run through the setup for Scaffold ETH just to make sure we have it. So we'll do Yarn install, and that's going to install all the dependencies. This will take a while on your machine. I've already installed it, so it's already there. And then Yarn chain. So Yarn chain fires up a local blockchain. Basically, we have a local version of Ethereum running right here in this terminal. And what that means is we have a whole blockchain, but we also have a whole bunch of accounts that are full of this like kind of fake Ethereum, right? So we have a fake backend. We have a backend, it's like a fake blockchain with a bunch of accounts, okay? And then I'm gonna CD into Scaffold ETH and I'll Yarn start, and that's going to fire up my front end. So you've got a React front end and an Ethereum hard hat back end, right? So you've got a local blockchain and you've got a front end, and that's going to allow us to do this really cool developer loop where we can change something small with the smart contract, deploy the smart contract, and then tinker with it and learn and get and repeat that process. And once you get into that cycle, you're going to pick up Solidity very quickly. If you're a programmer or you know a little bit of coding, Solidity is not that hard of a language, and we'll be able to dive into it pretty quickly. So we've got our blockchain running, we've got our front end running, and now I'm going to do a Yarn deploy. And I'll put a reset on there. You don't need it right now, but I'll do it anyways just to get in the habit of it. But what we just did was deploy a smart contract to this address, right? And if we were on a public network, we could go to Etherscan and we could look at that smart contract. We could see the address and we can interface with it. But what's cool is with Scaffold ETH, we just have a front end that will just talk to that smart contract for us. So let's go ahead and just redeploy it real quick, just so I can show this happening. I'm going to make this a little bit smaller. Watch right here. So this is the front end. and it's going to change as we deploy our smart contract. So let me deploy a new smart contract, and watch this. This address will change on us after I reload, I guess. Maybe not. What did I do wrong? Yarn deploy. Oh yeah, it did change. It was hard to see because the blocky was the same color. Let's do it again. Let's do it again. So there's this red one, 9F, and then there we go. There we go. So the address is changing. We're deploying a new smart contract. Our interface is adjusting and pointing to the new smart contract, and we can see it here. Let's just make sure. Let's add a couple more exclamation points to our smart contract to do it one more time. This developer loop is super important to me. You can see how I'm hammering it pretty hard here. Okay. Oh, awesome. Yeah, great link to Scaffold ETH too. You can also just like Google Scaffold ETH. Let's see. And you'll find, good Lord. Yes, if you Google Scaffold ETH, you will also find it. But thank you for that link there too. It's in the chat. Okay, so you've got Scaffold ETH down. You've got your blockchain up. You've got your front end up. You're able to kind of fire off deployments. Now, this is the loop we want to be in. This is where we want to be, where we want to learn how to tinker with smart contracts and learn how Solidity works. So let's just zoom in on our smart contract and look at it here. We've got this string, this storage element, right? And we've got a constructor. So if we want to do something when the contract gets deployed, we can put that code in there. And then we have a function that lets us set. So we have this string purpose, and then we have this function set purpose. So we have a function that, what does it do when someone calls it? It sets purpose equal to some new purpose, and then it does like a console log here. And this console log is in Solidity, by the way, which is really interesting. So let's I'm going to grab some funds from the faucet, and I'm going to say hello world, and I'm going to set the purpose. There we go. And we see the purpose update. So I make a transaction here, and that transaction goes to my local blockchain, and it updates the value of the purpose running this code, right? And let's see, where does this console log pop up? Here we go, over here. So your console log is going to happen over in your hard hat node, in your backend. And this is kind of strange, like what? There's a console log going on here? What? It's actually really, really, really handy, because before this, what you would do is you would emit events. It's actually like pretty hard to debug Solidity. And Solidity does some things, weird things with math. There's no floating points. So if you ever want a ratio, you have to, or if you ever want a decimal, you basically have to use a numerator and a denominator. You really want to zoom in on that math and make sure there's not a rounding error or you're losing precision. Console log is super handy for that. And we'll get to that in a little bit, but just like for sanity checks as you work on your smart contract, this console log is going to be super valuable. And you can see here that my address is setting the purpose to hello, right? So that console log is super valuable, and we'll get into that a little bit more. Okay. So let's talk about the storage a little bit. Let's look at some. I think the best first place to start is to just look at primitives and data types. So what I like to tell folks is, and this is in the Scaffold ETH repo. You kind of go through this, then it says here's some documentation. It tells you where to edit your smart contract, where to edit your front end, where the deploy scripts are. But then it talks about learning Solidity. And I think this is one of the first places, like once you've got everything up, you are ready to learn Solidity. You've got this whole thing running. It says the first thing to look at is just primitives and data types, right? So let's look at that. And I have that over here too, but Solidity by example is what we're going to use here. So this is our dev loop. Our dev loop is, let's find something new that we want to learn on Solidity by example. Let's paste it into our smart contract. Let's deploy it, and then let's tinker with it within our smart contract. So let's just look at some of these primitives and data types. You've got uints, you've got bools. I'm assuming that most developers kind of know what a uint is, know what a bool, an unsigned int, a bool, an integer. But this is a weird one, is an address. And an address is not something you're probably used to, but that is something that's native to the Web3 world. Nice, thank you for the Solidity by example link. I'm forgetting these links. Okay, so what I'm gonna do is I'm gonna grab my front end address. I'm gonna paste it in here. And I'm gonna make sure this is public, and I'm just gonna add this address to our smart contract. Just a simple, like, let's add it in, let's make sure it works, let's see what happens in the front end. And look at that, that new address is now added here. And you notice there's a nice blocky preview, there's a nice copy link, like a lot of those things will come out of the box for you with Scaffold ETH. So a lot of this stuff is just gonna look and feel nicer than other alternatives. So here we go, we've got an address. For some reason, we're storing an address. Now, this is what I really want to zoom in here is writing a require statement. This is like the most important part probably, is that you can write rules within your smart contracts. So we're writing this smart contract and it's getting deployed to thousands of nodes all over the network. Anyone can talk to it. It's censorship resistant. We can't shut it off. But these rules are going to be super important, right? So you use a require statement. We're going to say something like message.sender, and that's a global variable that says who's clicking this function, who's running this, right? And we're going to make sure that that's equal to the address, or we're going to throw an error that says not the owner or something like that, right? So what we're doing is we used to have this set up so anyone can call the set purpose function. We have this purpose storage, anyone can call set purpose, but now we've changed it. We've added one small line and we said, we're gonna keep track of this address. You know what, maybe we should call it, let's even call it owner, right? It could be anything we want. It's an arbitrary, I'm gonna call it owner just to make it make sense. And then we do a require statement. We require that the message.sender is the owner. And here we go. Let's deploy this thing and see what happens. Let's see if it compiles, make sure I got all the semicolons in there and everything. There we go. All right, so our new contract is deployed to 227 EB. We are the owner. And sure enough, I bet we can say hello world here. And hopefully this will work. It did. Okay. But how do we test the opposite, right? Now, when you're writing smart contracts, a lot of the time you will build an extensive test suite that runs through this. But right now, we don't want to be building tests unless you're a test-driven developer person and you like having those tests ahead of time. Right now, we're just kind of figuring out how the heck this thing works, and we're just kind of poking at it and tinkering with it, right? So here's what I'll do. I'm going to make an incognito window, and I'm going to go to localhost 3000. So I'm going to go to my app from an incognito window. And this is going to show us how wallets work within Scaffold ETH. You can see that I have a different wallet here. See how this guy is kind of like purple, like teal and red, and this is kind of like blue guy. Let me just close that and open it up again and go to localhost 3000. We'll get a new address. And this is an incognito window. It's using a private key and local storage. It's great for development, but you usually won't use burner wallets in production. So this is just kind of a nice to have as you're building. So we kind of have two characters here, right? We have the owner character interfacing with a smart contract here, and we'll just call this this is kind of bad guy. This is a bad guy character. And we'll grab some funds from the faucet. Again, you have a local Ethereum node, so it's easy to grab funds. You can even like say, send $1 million to this guy, right? I don't even know if that was enough zeros. But now this character, this account has a whole bunch of fake Ethereum, right? So what we want to do though is try as this account to set the purpose, right? And we have this set purpose function, and hopefully it won't work, right? We should get an error. So if I say this shouldn't work and I try to fire that off, there we go. We get an error. This is not the owner. So this is kind of the mindset you want to have as you're starting to work on smart contracts, is these require statements are super important. We have this set purpose function, and now only the owner can set that purpose. And we have that nice require statement there. And so this leads us through, this is how we're going to learn how smart contracts work. We're just kind of like finding these topics, pasting them into our smart contract and tinkering with how they work. So the first thing is primitives and data types. We've got a string here, we've got an address here. Let's do a uint 256 public counter, and we'll set it equal to 5, right? And then maybe we'll create a new function called increment, and we'll make it public. And what does that increment function do? Well, it probably just does like counter plus plus, or counter plus equals 1, or counter equals counter plus 1, whatever your flavor of programming is. And let's go ahead and deploy that, and let's see. And I'm just going to go ahead and close bad guy. We don't need bad guy anymore. We just destroyed $1 million of fake Ethereum, right? what we want to see here is there's our counter. Okay, so we're learning primitives and data types, right? So an address is a primitive, a string is a primitive, and a counter, like a number, right? And when we hit increment, that creates a transaction. So this is like a super simple example. We're just incrementing a counter, but what's actually happening here is we're deploying a smart contract. If this was live Ethereum, now this is local fake Ethereum, so it's not that big of a deal, but if this was live Ethereum, we would be deploying this smart contract to thousands of nodes that are all communicating peer-to-peer. And when we wanted to interact with that smart contract, we would craft a transaction, and that transaction would go into the mempool, it would get mined into a block, and then all the nodes in the whole network would increment their count by 1. So you have thousands of nodes. When you think about a database as a backend, and you think about redundancy, and you have read replicas, and you scale horizontally, imagine the whole network is a replica, right? Like each node on the network is keeping track of your counter. And when you increment that counter by 1, everyone in the whole network has to increment their version of that counter by 1. So writing to this database is very, very expensive. But reading from this database is like super easy, and anyone with a node can do it. You can ask any node on the network what my count is, and they'll be able to tell you. And it'll be cryptographically backed by smart contracts and blockchain and all that stuff. What happens after a smart contract is deployed? I probably need a little bit of zoom in on that question, because I'm not sure exactly what you mean, but this kind of illuminates this, like everything is a transaction. Even deploying a smart contract is technically a transaction. Let's do it again. Let's do a deploy. Now watch this. We'll see. There we go. So this is a contract deployment, and we paid almost half a mil in gas. So that's that would be $400 or $500, $600 on mainnet Ethereum right now to deploy the smart contract. But what it is we're just making a transaction. We're compiling the smart contract into bytecode, and we're making a transaction that says this bytecode is my transaction, and where the to address in that transaction is actually empty. And everyone on the network notices this new transaction that goes to no one that has bytecode in it. That's a smart contract deployment. And all of them on the network, all these nodes, grab that and say, okay, now this is a new smart contract. And then, okay, we probably should talk about the EVM a little bit. The EVM is this little computer that runs on all these other computers. It's a small little VM. And when you deploy a contract, it's like saved and everybody has it. And then they run any changes you have against their little VM. So when I say I would like to increment this counter, and I would like to call this function increment, then everybody in the world that has one of these nodes runs that little increment function within their little VM, and they get the result back, and they write it to their storage. So there's kind of a lot going on in that protocol layer, but let's just kind of probably abstract that away. Let's black box that, and let's just say, this is our zone to play right here. We have our smart contract. The syntax is pretty easy. It's almost like a little embedded controller, right? It's like a simple language where we're controlling simple storage, and that storage is super expensive. But this allows us to build these incredible vending machine type things where anyone can get to it, and we can create a market in 2 lines of code. So let's dive in and kind of get a little bit more into the weeds with Solidity. Let's see. So we've got our counter. We've got our counter plus plus. I'm going to change this to decrement. I'm going to do counter minus minus just to show underflow. So this won't underflow. This is not going to let us underflow. We're going to get our counter at 5. We're going to get a decrement function. And as I get to 0, it's going to start throwing. If I try to subtract 1 from 0, what's that going to do, right? So what happens is underflow happens. And in Solidity 8, it doesn't allow us to do that anymore. But let's just go ahead, watch this. We'll do unchecked, and we'll surround that, and we're not going to check for underflow now. And then, and actually, let's make this a uint 8. So we're going to use, instead of 256 bits, we're going to use 8 bits to keep track of this number. So if we use 8 bits and we start at 5 and we create a decrement function and we decrement that 5, 4, 3, 2, 1, 0, we're going to subtract 1 from 0 here. Here we go, 5, 4, 3, 2, 1, 0. Now, since it's unchecked, it's going to let me subtract 1 from 0. Now watch what happens here. It rolls over. See that? So it goes to basically the highest possible value. And you just want to kind of be aware of what's going on kind of underneath the abstraction a little bit, right? Think of this like a little embedded controller, and it has a little storage with 8 bits, and it's storing our number in it. And as we, subtract or add to that, those little bits are, decreasing or increasing. And so if it's all zeros and we subtract 1 from it, all of those bits go high and they're now 1s, right? And that's where that 255 comes from. So normally you probably won't do a lot of unchecked math. You probably won't really worry about the bits too much, but just kind of like showing you some of these primitives and data types. Okay, let's assume that we've got our primitives and data types out of the way. Feel free to ask questions in the chat. Feel free to DM me on Twitter if there's more to look through there. Oof, gas is hot right now. But let's look at the next. So I'm at the Scaffolding repo. I've set all this stuff up. Now I'm at, we figured out primitives and data types. The next thing to learn is mappings. So let's go learn it. Like, let's figure out how it works. So a mapping is basically a mapping from one data type to another, right? In this case, we've got this mapping that maps some address to some uint called my map. I'm just going to copy and paste that. I'm going to grab that. I'm going to paste it right into my contract, and I'm going to hit save, and we're going to deploy it. So it looks like for any given address, it's going to give us a uint. And you know what? I want to be explicit, and I'm going to say that's a uint 256. I want to make sure I know exactly how many bits that is using. This is the same thing, by the way. Uint and uint 256 are the same thing. I just like to have the 256 there because it's like obvious this is a 256-bit uint. Okay, and we've deployed that. And now over in our front end, where is it? Let's go find it here. We should have this my map now. And you'll see that the front end gives us, well, you put in an address, and I'll give you a number back, right? So we're keeping track of some number for every address. It's a mapping. So I could maybe put in this guy's address, and it's 0. Okay. So let's say my map of the owner, right? Or we could even just paste this right in here. Let's say set it equal to 100. Okay, now it's 100. Let's go ahead and deploy it, make sure that works. Grab some coffee, questions in the chat if you have questions. Hopefully we're covering this pretty well. Now when I ask for my map, let's see what it is. It's 100. All right, whoa, VM exception. Whoa, what? I don't know what that is. Oh, that was the decrement. Oh, I see. Okay, that was the error from the. Okay, that was from a long time ago. Okay, I should let's make sure. That was scary. Okay, we're good. Okay, so let's see. Let's clean this out. We don't want our counter anymore. Our owner is fine. Our purpose is fine. I don't know. Let's leave it in there. Let's have all this stuff. What I want to do now is show this mapping and how this mapping works. So this mapping is allowing us to kind of keep almost like a little registry of who has what, right? We have an address has some amount, right? And let's do, that's good. Let's grab maybe another bad guy, and we'll go localhost, and we'll grab their address, and we'll give them 50. There we go. Okay, so let's grab this address and let's give them 50. Okay, and let's go ahead and deploy that. So now we have 2 accounts, this account over here and this account over here. And if, for instance, we check the my map for this guy, it's 50, and the my map for this guy is still 100. Cool. There's a question here. Yes, the process of nodes updating, basically what, so there's like a whole network. If you hit up, oh, there's a Q&A. Oh man. I'm gonna need to answer these questions. So if you hit up eth.build, I talk through what happens when a block gets mined. If you go find the blockchain section. So basically what happens is when someone finds a valid block, that gets transmitted to everyone, and everyone says like, oh, that's a valid block, and they stick it on the end of their chain, and you follow the longest chain. And what can happen is you could have, I find a block in Colorado and someone finds a block on the other side of the world, and just due to network propagation, there's 2 different chains that form, right? And then another block, what happens is whoever finds the next block then will follow the longest chain. So you can see like a little bit of reorg and stuff happening there. And yeah, get into eth.build and check out this blockchain video, and it will explain, hopefully answer that question about, you know, what happens. Awesome. Good to hear that. That makes sense. Okay, let me just real quick, can you talk through the flexibilities of smart contracts? Yes. Okay, we'll get into the ERC20 standard and 721 for sure. Like we'll get there real quick here. Emit, where do you emit a message? Okay, so that might be events. We'll talk about events in a second too. Smart contracts are vulnerable. Yes, I mean, like smart contracts are as vulnerable as you make them. Like there are certain things like that underflow error that I just showed there. You have to understand how underflow works. And if someone were to figure out how to overflow your variable, they could, it's vulnerable, right? So the vulnerabilities, the code is doing exactly what it's programmed to do, but like you need to understand what it's doing, and you need to understand those bits and how that underflow works. So in terms of smart contracts vulnerabilities, you kind of need to understand what you're building here and what's going on kind of underneath the abstraction to make sure you don't get yourself in trouble. And when you deploy something to mainnet, you should have it heavily audited. What we're doing here though is we're tinkering. We can maybe deploy to a testnet if we have enough time, but yeah, your vulnerabilities, you want to learn those. And again, Solidity by example, right? Oh, not Solidity, read the docs is great, by the way, but Solidity by example. Oh man, come on. Solidity by example. Here we go. We're going to get it. We're going to get it. Here we go. If you look all the way down here, there's a great section of hacks, and it will take you through each hack and how it works. Go reproduce these. If you're really interested in vulnerabilities and attacks, go reproduce all of these attacks. Okay, so we're learning mappings. We've got this person and this person each have a mapping. What's starting to hopefully kind of show up in your head here is this mapping is kind of like a token, right? Which basically like we can send ETH around, but we can also send a token around by just keeping track of who has what, right? So let's just change this to balance, right? We're going to say each address has some balance. And then we'll go ahead and set the balance of this dude to 100 and the balance of this dude to 50. Let's go ahead and deploy that and make sure it works. And that's going to be 150. We've already seen that already for each point. What we need is a transfer function, right? So let's build a function called transfer. And there will be an address to and a U256 amount. Okay, and we'll make that public. Now, what happens in a transfer? Well, we are going to say that the balance of message.sender, right? The person who's calling this function is going to go down by the amount, and then the balance of the to address is going to go up by the amount. And we just built a transfer function. Now, obviously, you would want to do some checks to say, like, is this balance greater than the amount? But in this case, since we have Solidity 8 and we know that that underflow is going to break, if they don't have enough, this is just going to throw. So we basically could just make those two statements in that function. And if anything doesn't work, it's going to fail and revert. So now we've built ourselves a little token, right? We have a balance. I can check my balance and it's 100. And I can check this dude's balance and it's 50. Now let's transfer, right? If I want to transfer, if I grab his address and I paste it in here, you get a nice little blocky preview, right? It's that one. And I send 10, right? Then if I go check this guy's balance, it's 90. And over here, this guy's balance is 60. Okay. So now we've kind of created a token, right? We've created a mapping of balances, and we created a transfer function. Now, the gotcha here with a mapping is that we can't iterate through it. If we needed to have a smart contract understand who, or let's just say we need the smart contract to on-chain tell us who has the highest balance, we can't really do that in this case. You would need to iterate through all of the balances and find the one that is the biggest. With a mapping, you can't iterate through. A mapping is kind of like a hash map where it's like, okay, you have this address and that goes to this endpoint and there's no way to iterate through them. So that's the gotcha with a mapping. But really, if you want to create a token, this is like super easy. You create a mapping, you create a transfer. Now, obviously, we talked about the ERC20 standard. Obviously, the ERC20 standard is going to be a little bit more complex. It's going to have things like allowances where you can approve some other address to take funds, but technically it's basically just that transfer function and some balance that it keeps track of. But there's, some more things like you can transfer from and approve and allowances. So there's more to the standard, but just kind of getting over the mental model of what that looks like. It's basically just this mapping. Now, one thing we haven't hammered on, and we're kind of getting into the closing time here, is ETH versus Way. Let me just show it somewhere. There's probably some kind of good, here we go, ETH converter. Okay, so right now we're talking about what is 1 Ether? 1 Ether is actually this many Way. Okay, and the reason why we do this is so we can have decimals. So with this 50 and this 100, I can't do any decimals. Okay, so what I'm going to do here is I'm going to say this is 100 Ether, and this is 50 Ether. And all that is doing is actually taking it times 10 to the power of 18, which you can also do like that. Okay. And so now this is going to let us, so if this character wanted to send 1/2 to this character, it wouldn't work in our current setup. But now that we've set this up with ETH instead of Way, which is how all tokens work, they've almost all of them basically have 18 decimals, and that allows you to do basically like fractions, right? Sending some. Now this is going to change a little bit. If I go ask this guy's balance now, it's 100 E, right? See that little E there? And that's actually the balance. If we were to ask for it in raw format, is 100 times 10 to the 18. So a whole bunch of zeros there, right? And if I send one, let's go back to our transfer function now. If I want to send one to this guy, now if I send one, I'm going to be sending 1 Way, right? So you'll notice as a developer, you have this times 10 to the 18. I'd like to send 1, but with all those zeros, so we have the decimal. And hopefully that makes sense. It's kind of confusing, but let me go ahead and do that. And now if we go check this dude's balance, it should be 99, right? Yep, I sent 1 ETH worth. So that's another little gotcha that you'll get when you get into here is you want either Ether or Way. And the way I was doing it earlier with just 150 is easy to understand, but we're just sending around Way, which is just like dust. It has no value, right? So you want that times 10 to the 18, so you're sending around the right thing. Okay. So let's see, we've gotten started. We've been able to push this. The difference here between, we talked about the ERC20 versus ERC721. So this is an ERC20, basically. You've got a mapping to a balance, you've got a transfer function, and it's a fungible asset. Basically, every user has some balance. Alice has 10, Bob has 10. Bob sends 5 to Alice. Now Alice has 15 and Bob has 5. You're just keeping track of who has how much, and you're kind of incrementing and decrementing as those get sent around. Now, an ERC 721 is a little bit different. It basically has given for some unique ID, right? So this is turned around. So for some ID, there's an address owner, okay? And so there's these unique tokens, token 1, token 2, token 3, and each one is owned by some address. So the ownership pattern is kind of flipped around. Instead of an address having a number of a balance, in this case, it's a number of balance. It's a unique token has an owner, okay? And when you transfer, then you would say, the owner of asset number 2 is now the new address, right? So your transfer function is a little different too. But that's basically the kind of the inner guts of the difference between a 721 and an ERC20, fungible versus non-fungible assets. Again, if you're a programmer, you're a coder, you can get in here and just start programming these. So you can say, well, let's see, we need to keep track of a counter, we need to keep track of a balance. We can program all of these kind of basic things that we're talking about with basic coding skills. Let's do something real quick. I was talking about kind of like financial mechanisms and stuff. Let's clean out a handful of stuff here, and let's get down to back to our set purpose function. So we have just the owner. who's allowed to set the purpose. Let's take that out, right? Instead, what we're going to do, okay, so let me just go ahead and get it to that point and redeploy it real quick and make sure that we get our contract nice and clean. And I can say, hello world, and I can say, hey, and oh, this guy's not gonna have money. I need to go to, watch this. I'll get an error that says something about doesn't have upfront costs. You need to make sure you get some money from the faucet and then you can make a transaction. Okay, so we're able to talk to our contract. Now, as a programmer, you can make small little changes and create totally new financial mechanisms. Okay, so let me do uint 256 public price. We're gonna make a price function. I'm gonna set it to 0.001 ether. If you want to set the purpose, I'm going to require that the message.value, okay, instead of looking at message.sender, we're looking at a different global variable called message.value, and I want it to be greater than or equal to the price. I'm gonna say not enough, okay? And then there's one other thing I need to do. I need to make this function payable. There we go. So payable functions, mappings, and primitives and data types, that's like level 1 of Solidity. Once you've tackled those, you've basically got, like, you can build like 80% of the smart contracts you see today. And so what we've done is we've created this set purpose. And if I say hello world, you'll notice now there's a little transaction value thing. I need to put in 0.001 and it needs to be ether. And watch this. So I have 0.009, right? Now, when I hit send, this is going to go down. I'm going to pay some money. Not only am I paying a little bit for gas to make the transaction go through, I paid 0.001 ether to the smart contract. And now this smart contract is actually holding $2.78. Now, this is really interesting. Now you're starting to see, like, these are vending machines. These are these really cool vending machines where you only have to trust the code. You can get in here and see the smart contract is checking this. You can see that you're sending in value. Okay, so I get the rules of this vending machine. Now I know how to interact with it. And anyone in the world can interact with it, right? So this is bad guy, right? We want to think about this network is a sort of adversarial network. It's a network that allows a bunch of jerks to coordinate. And obviously we're not all jerks, but if you can think about it like that, if it's an adversarial network where you're able to coordinate with people you don't trust, it becomes very, very powerful. And so let's go ahead and just let's let the jerk, I'm a jerk. Let's let the jerk pay some money, and let's make sure that works. And there we go. And what if they don't pay the money, right? No. Let's say if they pay 0.0001 ether, right? Like they pay some money, but not even enough. It should say not enough, right? And we're able to test that. Now that's cool. We've got a price function. Okay, our price function is working pretty well. Let's do something a little bit different. Once they pay, and let's do something, let's say price equals price, times 101 divided by 100, okay? Now you can't do decimals. I can't just say times 0.01. I have to do it like this. But now let's try this. And what should happen here is we've created a whole new financial mechanism. We basically said, okay, you can set the purpose of your contract if you'd like. Oh, that's weird that went up to, let me redeploy one more time. The value should be 0 and it was showing that it had money in it. Okay, now what we've done is we've created a new mechanism. We've created a price curve by adding that one line of code right here. That's simple programming. We've actually created a price curve within our vending machine. Now, if I say hello world, notice the price right now is that, and I go ahead and send in that price, which is the same thing as doing 0.001 and taking it times 10 to the 18, right? So we're paying some small amount, $2 or whatever, and we pay that. But now the price goes up. Aha, if I pay that same amount again, it's going to say not enough. So with each time someone sets the purpose, the price of setting the purpose goes up by 1%. And we're able to do that with this stupid simple line of code. And that's kind of like the superpower here, is you as a programmer can code these simple lines of Solidity and create these new mechanisms, these vending machines that anyone can get into and poke around with, play with, and use and not have to trust. They basically only have to trust the code, right? And the overall security of the network. And there's a lot more that you've learned about consensus and proof of work, proof of stake eventually. But this is the key. Okay, now in the last 4 or 5 minutes, I want to do kind of just like where to go from, share your brief thoughts on Solana, IDK. I'm an EVM maximalist, so all of the tools for Ethereum, they're EVM compatible. Anything that's EVM compatible, I'm all about. If I can deploy an EVM compatible thing, IDK about Solana, I've never used it. Like I've deployed, for me, when I want fast, quick transactions, I have Optimism now, right? So there's L2s that are settling to Ethereum that have better security concerns. When you're looking at these other L1s, figure out what have they traded off in terms of decentralization, security, and speed. And somewhere in there, there's a trade-off. And obviously, like, it's great. Like I am a builder on top of this stuff. So like not a gigabrain. There are gigabrains that can debate this forever. So I won't get too deep into that. But if you want those quick, fast, cheap transactions, check out L2 and Optimism and Arbitrum and ZK Sync and Polygon. Okay, so here we go. In the last few minutes, let's say you are able to kind of crush through and learn some Solidity. You're able to build some smart contracts. Let's say we like this thing with this price curve. I'm going to do a yarn build, and I'm going to actually no. Let's just go ahead and deploy this. How much time do we have? A few minutes. I'm going to do a yarn generate. So right now I'm deploying locally to my account. What I want to do is I'm going to create another account. I'm going to create a deployer account with yarn generate, and you'll see this in the documentation. You'll see this in the README. I just want to show an app going all the way. You probably won't get to this for a bit, but I'm going to do that, and then I'll do yarn account. I'm going to deploy to some test network, maybe Kovan because it's faster. So I'm going to select, I'm just going to send a little Kovan to this address. Scan, allow. And then I'm going to send like $100 worth of Kovan. Okay, so in 5 seconds, this account will have some Kovan. Now what I want to do is I'm going to do a yarn deploy, just like I was doing before, but I'm going to say network is now Kovan, right? Everything else is exactly the same. But instead of deploying to my local chain, I'm about to deploy the smart contract we built to a public network where other people can interact with it. Here it goes. It'll take about 5 seconds. And then once it deploys, the cool thing is we're going to get into our app. This is the first time we've even touched the front end code. And I'm going to change the app to point to Kovan also. And now all of a sudden, this app that we've been playing around with locally, I'm going to go ahead and just close my local blockchain. I don't need it anymore. I've got my front end, and now the smart contract lives on Kovan. And if I reload this, it should hopefully connect to our contract on Kovan if it went out there. Okay. And what I can do there is I can do a yarn build, and eventually I can deploy my app, and anyone can go to a URL and interact with. It's not looking good. Let's see. Let me make sure. Let me connect my MetaMask now. Let's see. Is it on Kovan? Let's get this on Kovan. Let's see where we are here. Something's not working with our app. But this is this whole setup with Scaffolding, the fact that we have all this stuff locally gets you quickly to this point where you can deploy your contract to a live network, and you can point your app at that live network. I don't know why. Maybe Kovan's not working. I don't know. We could try a different network real quick, but I'd have to run through some things, and I think we're close to being at the Q&A time, I think. Smart contracts, vulnerability. Okay, yeah, I think I covered that. I think I have everything in the chat answered. Now is a great time for Q&A. Throw it into the chat. I will probably like keep tinkering with this. So next steps. I want to give you guys a handful of next steps. So first of all, get Solidity. Get Scaffold ETH, get Solidity understood, and start working through some of these more advanced topics. One is structs. I think structs are pretty important. So what you can do is you can create a struct of primitives and data types. You can create an array of those structs, and then you can do things like add things to that array. So back when we were talking about that mapping and we were saying you can't iterate through it, say you need to keep track of votes and you need to iterate through all the votes and figure out who won, you'll have to use this kind of structure where you have a struct, you add them to an array, and you push them onto the array. And then in your read functions, you can just loop through those arrays and check to see on votes and stuff like that. So that's like the next step after primitives and data types, mappings, then get into structs and arrays. Shoot, we didn't cover events, but the best way to look at an event is right here in your smart contract. If we uncomment that and we uncomment that, and I don't know, what are we gonna do? Redeploy this thing to Kovan? Let's do it. just live redeploy this. Let's see what happens. Here we go. But an event is basically a smart contract can emit some information, and that information can be read by your front end. The gotcha with events is other smart contracts can't read other smart contracts events. So if you need a smart contract to talk to this smart contract, it's going to have to be on chain. It can't be an event. But events are really nice for on-chain storage that only the front end needs to read. For instance, if you had a multi-sig wallet and you wanted to keep track of withdrawals and deposits, and a user deposited, you wouldn't want to just show them their current balance. You'd want to show them the history of withdrawals and balances. And you do that by creating an event for each one of those things and then just deploying them, showing that off on the front end. Let's see, our Kovan front end is not looking good though. I feel like we need to probably switch back to localhost. Let's see. Security aspects, yeah. So I think that like you're going to need to understand overflow. You're going to need to understand all the attacks. Go look at Solidity by example again, and look at those attacks. If you're really like, smart contracts are complex, Solidity is complex, decentralized platforms are complex. So right now we're just tinkering, but know that there's a ton of knowledge to learn about the gotchas and other things, and just get into these attacks and understand what's going on. Understand how overflow causes a problem. Understand how you could create an app where someone can grief the app. If it's not written correctly, there could be a denial of service against the app. Understand, yeah, like front running and MEV stuff. Understand honeypots, malicious code, and external contracts. There's just a ton of stuff to look at here, and new hacks happening all the time, and you can get in and learn about those. But this is where I would say, like, this is where you want to get into. And also, if you look at Solidity, all right, so we really got to close this out soon, but if you look at Scaffold ETH, there are tons and tons of branches. So if I go to the Scaffold ETH, I don't know what this is called, the Scaffold ETH group, I'll post it there. The Scaffold ETH, what is this? Organization, Scaffold ETH organization. There are Scaffold ETH examples, and I will paste those in here now. So say you wanted to learn about that honeypot. There is a perfect honeypot example in Scaffold ETH that teaches you through that, how that works. Or reentrancy, right? If you want to learn about reentrancy, here's another Scaffold ETH example. So it's all built with the same stuff, but the contract is set up to teach you through some of these kind of concepts of security. Man, what is happening with Kovan? I'm so sad that this didn't deploy correctly. Maybe if I do a Yarn account, let's just pick another testnet real quick. I feel like this is important enough to see. Let's go with Rinkeby. See if I can get some Rinkeby on this account. Yeah, he's got Kovan. He deployed the account, but it's not. Let's send some Rinkeby in here. Send $100 worth of Rinkeby and see if I can deploy a contract to Rinkeby. More questions, throw them into the chat, hit me up. By the way, I'm using a Punk wallet, so punkwallet.io. It's built with Scaffold ETH. Another app that's built with Scaffold ETH is Nifty Inc. It's an NFT platform. So lots of great stuff built with Scaffold ETH, lots of stuff coming out all the time. It's a great just like app building platform, and it'll get you to building apps quickly. Let's try a Yarn deploy on Rinkeby just to see if it's maybe the network that's down here, or if there's something wrong with Scaffold ETH that I need to go attack. So this will take longer. Blocks on Rinkeby, let's go through the test nets real quick. Kovan, 5-second block times, great for doing DeFi type stuff because it has things like Chainlink on it. Rinkeby, 15-second block times, good for NFTs because you can use it on OpenSea. So Rinkeby for your NFTs, Coven for your DeFi. Then there's Ropsten, which is a proof of work network. So the blocks are very slow and weird. So if you need to test user experience and make sure you've got your dialogues and prompts working well, try it on Ropsten. And then Goerli's for the cool kids. Goerli is a newer testnet. I don't know exactly like what the selling point is for Goerli other than it's cool and cool people made it, but it's a cool testnet also. All right, let's see. Rinkeby, we're going to go to our front end. Let's see if we can figure out how to get this live smart contract working. Rinkeby. Now, hopefully, our front end should be pointed at Rinkeby and should be pointed at our smart contract that is deployed here. Something is wrong. Looks like Austin needs to fix something. I don't know why it's not finding our contract. Let's see. Let's go see if our contract is deployed. Let's check that part first. Is our smart contract deployed to Rinkeby? Yes, it is. There's the contract right there. So for some reason, something broke very recently in the Scaffold ETH stuff. Oh, let's get this on Rinkeby. Yeah, something is not right here. I'm going to have to bug somebody about this. We'll have to figure it out. But assume that this will this will work when you pull it down later today, because I will attack this with some devs and we'll figure out why this isn't working. But with Scaffold ETH, you can deploy, you can tinker, you can figure out your solidity, and then you'll have an app that is on a live network that lets you tinker with that app. I wonder what we're doing wrong. Going to definitely have to hit some folks up here. Okay, let's see. Is there anything left to show off here? Okay, next steps. So you've got your app, you're able to deploy a smart contract, you're able to tinker, you're able to get an app going. The next steps here are to speed run Ethereum. So speed run Ethereum is a course that I've set up that from hours of mentorship sessions, figuring out what works and what doesn't, I've created a curriculum here that will work you through learning the mental model. A decentralized staking app is kind of the superpower of Ethereum, getting those jerks to all coordinate. A token vendor, learning how to deploy a token, learning how to deploy a vendor. It's kind of contract to contract interaction. Then you'll get into multi-sigs and building a DEX. So get on here, create your builder profile, and you'll take on some challenges and kind of create your Web3 profile. And then from there, there's so many different examples. I have a tweet thread that takes you through. If you just go look at my pinned tweet here, the sort of like the 3 steps are basically learning Solidity, getting the Solidity down, getting Scaffold ETH up locally, running through that speed run, and getting kind of the initial kind of challenges tackled. And then there's just this like super thread right here, and I'll post that into the chat, of just like, here are next steps. Like, here's how you get yourself out of tutorial hell and actually like build something cool. There's just like 40 different things you can build next. They're gonna show you different things like building an executor, building a multi-sig, learning how LP tokens work and building a DEX, figuring out SVG NFTs, looking at IPFS, understanding ZK tech, looking at randomness on chain. Randomness is really hard on a deterministic public blockchain. Building a transaction indexer, also like super hard. It's like actually really hard to like index all the transactions, like talking to a node, learning about delegate call, learning about token gating, learning about deploying to another network like Optimism, just double checking a lot of your knowledge and making sure you know how things work, looking at leverage and DeFi, other starter kits in the space, other flavors of Scaffold ETH. So all of that stuff is here and can help you get started. I think, let's see. So what do we need to know for front-end development? In this case, you will need to know some React. So there is the React app. If I go to app home, this React app is like basic React. You'll need to know how to do props and how to do some use effects here and there, right? So if you only know JavaScript, you probably want to get into React and just build yourself a little to-do list. Build a simple app that you will use in React and kind of like iterate on that, kind of use it, find the problems with it, improve it, just to upgrade your skills in React. There's not a lot of like a deep knowledge of React that you need, but you need a light knowledge of React to be able to build a lot of this stuff. A lot of the components will be there for you kind of out of the box. Let's see. Latest version of Solidity is always buggy. I have not had that experience. I try to stay pretty up to date with the latest version of Solidity. Here we're using from 8 to 9. I don't know if it's buggy. I haven't had that experience. I like to stay up with the latest stuff. The hard part is you'll have stuff like OpenZeppelin, and maybe they won't be, I mean, they are up. These are like, if I bring this in, this should work. But, oh, whoa, I'm deploying to Rinkeby. But sometimes the libraries you bring in, like from OpenZeppelin, may have a different Solidity version, and that's where you'll have to tweak that. But almost always, I like to keep 8.4 as my, or 8 as one of my versions. Let's see, can I do this too? Just kind of tinkering around here. What's another question? How can we make sure that contracts are performant? Again, like, it's just a ton of knowledge. You'll have to get in here and understand. I mean, there's things that I didn't do in this contract that could help. For instance, this owner could be constant, right? Address public owner, where it's never changing, it's not moving. So I could probably say put constant, right? Maybe, let's see, and we can do a yarn compile and make sure that is the right way to do that. But basically it's that, right? You need to understand kind of what's going on, what costs what, like each one of these things, each one of these steps costs a little gas, and you need to understand, like, is this a super expensive or is this not? And for instance, let's say we set the owner to that, and then in the set purpose, for some reason, we set the owner again, like that would cost, but not as much. The first time you set something, it costs you like 20,000 gas, but the second time you set something, it costs like 5,000 gas. And you can see that over in the hard hat terminal. You can see how much gas things are costing. So you can kind of like tinker around with that and see them show up there. I think I have everything. Any like last questions or anything else? I can probably stop sharing my screen too. Cool. Yeah, I'm open to any closing questions. I'm watching. Hopefully I didn't miss too many questions. Hopefully that covered everything. Check out Scaffold ETH, check out Speedrun Ethereum, hit me up in the DMs. My DMs are open. Hit the Scaffold ETH chat for more questions. Anything else? Any other questions? Happy Tuesday, everyone. Go build something cool on Ethereum.
Thank you so much, Austin. So is there any other question? Anybody has any questions? One last question. I think we have one in the Q&A.
Is there a specific backend technology stack that would be useful to know as a prerequisite? JavaScript, probably, like know for loops and understand how to do basic stuff with JavaScript. If you wanted to like have an kind of a next step that isn't like Scaffold ETH and Remix, I would check out Ethers.js. You could go look at just like write a script with Ethers.js that creates a wallet from a mnemonic, and if money is sent to it, then you check the balance, and if there's money there, you send it somewhere else, right? Just write a little script that sends money around using Ethers.js. That's probably like a good like half step toward learning some of these more advanced topics. But yeah, I think JavaScript is probably the basic. Understand JavaScript, build something in React that you'll use. Maybe it's just a dashboard that tells you how much ETH you have in your account and what the current block number is and how many transactions happened that day. Something like that to get you started just tinkering with stuff. Thank you. Thanks for the thanks. Hearts everyone for having me. This has been a fun session, and I can't stress it enough. I'm going to put it into the chat again that you should speed run Ethereum. Thanks a lot. Thank you. I think that hopefully that link works. Yes, it does. Go speed run Ethereum. Get Scaffold ETH pulled down. Tinker with smart contracts. Tinker with Solidity. Start learning. take on those challenges. And then there's a whole tweet thread of things that you need to know. But just getting the syntax will get you up that Dunning-Kruger and make you feel like you can build anything. And then you have to kind of go down the pit of despair and learn how hard it is to actually build those things and get close to like, okay, this is actually something that the world needs. I'm going to build it and ship it. Thank you so much for having me. Any final questions?
Thank you so much, Austin. I guess if no other questions, then we can end the session. Thank you, Austin, for being so energetic and answering all the questions and providing an excellent session for all our members. Thank you. Really appreciate your time.
Thank you for having me.
Thank you. Thank you to all the attendees as well. If you have any questions, reach out to us on Slack, and also Austin is there on Twitter. You can reach out to him as well. So thank you all. We'll be ending the session now. Bye-bye.